All right, let's talk about Apache Kafka consumer lag. If you operate distributed systems at scale, you already know Kafka is the unbreakable backbone of your data pipeline. Well, at least until it isn't. In this explainer, we're putting on our senior distributed systems engineer hats to figure out exactly why your event system is falling behind, and more importantly, how to proactively tune it for ultra-low latency.
We have all been there, right? It's 3 a.m., your pager's screaming, downstream services are completely starved for data, and your records lag max metric is just exploding off the charts. Look, to fix this permanently, we can't just slap a quick band-aid on the application code and go back to sleep. We really have to dig into the underlying mechanics of consumer groups and, honestly, take a hard look at your bare metal infrastructure.
Here is our roadmap for the explainer today. We're going to cover the anatomy of lag, the dreaded stop-the-world rebalance, partitions and scaling math, infrastructure bottlenecks, and we'll wrap up with some concrete, proactive tuning strategies.
Okay, starting with Section 1, the anatomy of lag, and really defining what this pain point is.
Fundamentally, consumer lag is just an offset delta. It represents the exact volume of in-flight messages your system is currently starving for. Now, a small, stable lag, that is completely normal. We expect that. But a rapid, vertical spike, that's a lag explosion, and it means your consumers are officially drowning.
To give you a sense of what's actually possible when you conquer this lag, consider a recent case study from a Tier 1 global investment bank. They sustained a mind-blowing 1.6 million messages per second, all while maintaining a sub-5 millisecond P99 latency. That is absolutely staggering throughput, and it just proves that Kafka can handle extreme workloads when it's tuned correctly.
But getting to that elite level requires a massive shift. You have to move from a reactive posture to a proactive one. If you're sitting around waiting for downstream timeouts or user complaints, you've already lost the battle. You need to actively monitor your JMX metrics, specifically watch records lag max for your volume and rebalance latency max to see exactly how much time your consumer group spends frozen.
Which brings us to Section 2. Let's examine that hidden mechanic, the stop-the-world rebalance.
When a consumer group rebalances, it executes a very strict 5-step protocol coordinated by the broker. From the initial trigger to rejoining, getting assignments, syncing, and finally resuming, this entire process acts as a complete stop-the-world pause. During this time, your consumers cannot fetch or process a single message. And let me tell you, lag builds up every single millisecond this is happening.
Now, some rebalance triggers are totally expected, like when you're intentionally scaling out. But the silent killer is that last trigger. If your consumer pulls a complex batch of data and the processing time exceeds the max poll interval MS setting, the coordinator just assumes your consumer is dead. So it kicks it out, pauses the entire group, and starts reassigning partitions. So literally, your slow application code just caused a cluster-wide traffic jam.
Let's move on to Section 3, partitions and scaling math, or how we parallelize consumption.
You see, Kafka's true unit of parallelism is the partition. Just look at the math here. If you have 12 partitions and 3 consumers, each instance is juggling 4 partitions. But if you scale out to 12 consumers to perfectly match your partition count, you instantly yield a linear 4x throughput increase. Of course, you do need to make sure your downstream database can actually handle that new fire hose of data.
But hold on, don't just blindly scale out just yet. Let's borrow a brilliant trick from that Tier 1 bank we talked about. They use the lowest baseline first method. You start with one topic and one partition, and you isolate your physical network latency. They actually found a floor of 0.3 to 0.4 milliseconds. You absolutely have to know your physical baseline before you start adding parallel complexity to the mix.
That leads us nicely into Section 4, infrastructure and tail latency. Often, this is the ultimate bottleneck.
Listen, optimizing for median latency is a massive trap. Your endpoint might show a beautiful 1 millisecond average, but that can completely mask an 80 millisecond delay sitting in the 99th percentile. This is the classic tail at scale problem. You have to aggressively monitor and optimize for the P99, not the P50.
To eliminate those rare P99 spikes, you need to look at your serious infrastructure. We're talking high-performance XFS file systems and enterprise NVMe SSDs to dodge disk lock contention. More importantly, set your Linux VM swappiness to 1 and deploy the Z garbage collector on JDK21. Because frankly, no amount of brilliant Go or Java code is going to save you if your JVM decides to pause the world for a 50 millisecond garbage collection cycle.
And finally, Section 5. Let's get into the weeds with some proactive tuning strategies and concrete configurations.
Let's start by tweaking the clients. First up, increase that max pole interval MS. Give your app some breathing room and stop those false rebalances. Second, bump up your fetch min bytes to around 100 kilobytes. This reduces chatty network requests and encourages the broker to send fuller batches. But most importantly, switch your assignment strategy to the cooperative sticky assigner. This enables incremental rebalancing. It means consumers only drop the partitions that are actively moving instead of suffering that full stop-the-world pause. It is a real game changer.
But consumers don't exist in a vacuum, right? You have to tune your producers and brokers to match. Try setting your linger mems somewhere between 10 and 100 milliseconds. This pools messages into larger batches and can literally double your throughput. Combine that with ZSD compression. And finally, make sure your brokers are running in craft mode. Ripping out Zookeeper entirely speeds up your metadata operations by a massive 30 to 40%.
I really want to leave you with this battle-tested truth from engineers operating at the absolute edge of performance. You can tweak software properties all day long, but if your disk array is saturated, or your network is chatty, or your garbage collector is pausing, your Kafka lag will inevitably spike. Infrastructure is the ultimate bottleneck.
So I challenge you this week, take a hard look at your systems. Are you truly tuned for the 99th percentile, or is your application code just hiding behind failing infrastructure? Dive into those JMX metrics, find your absolute baseline floor, and start optimizing, because the clock is always ticking until that next 3 a.m. alert.